For centuries, humans have looked at the moon and imagined ways to get there. In 1865, a French novelist named Jules Verne envisioned a giant cannon in Florida that would blast explorers into space. A century later, NASA realized that vision, trading the fictional cannon for the Saturn V rocket. We walked on the surface, planted a flag, and returned to Earth. Those missions were incredible sprints, but today the objective has moved toward a permanent presence. Building a home on the lunar surface requires thousands of tons of equipment and constant heavy labor. These requirements demand a specialized industrial workforce rather than a small crew of pilots on a short timeline. The moon is a notoriously unforgiving place. There is zero atmosphere to stop micrometeorites or block solar radiation. Temperatures swing from boiling hot in the sun to hundreds of degrees below zero in the shade, and the entire surface is covered in an abrasive dust that destroys machinery. Earth's logistical bottlenecks add to the difficulty. Global semiconductor shortages limit the brains of our machines, and the engineering required for orbital refueling remains one of the most complex puzzles in modern aerospace. To bypass human physical frailty and these terrestrial supply constraints, the first crew will consist entirely of machines. Deploying robots first allows us to encounter roadblocks and refine our manufacturing processes without risking human lives. This Vanguard consists of 200 Grok bots, a specialized fleet designed to survive the conditions that would be fatal to humans. Their engineering is rooted in advanced humanoid robotics, featuring limbs capable of heavy lifting and hands precise enough to assemble delicate electronics. The core advantage is their AI architecture. These bots learn and coordinate tasks as a unified team. Because of communication lag with Earth, these machines rely on localized intelligence to make split-second decisions without waiting for mission control. This makes the fleet an autonomous construction crew, built specifically for the complex groundwork of a lunar base. Launching this workforce requires the scale of a fully stacked Starship rocket at Starbase, Texas. Inside the cargo bay, the 200 bots are secured in protective cradles, their software fully synced with Earth's AI systems for the journey ahead. The launch sequence generates enough thrust to push the payload into orbit, followed by a clean stage separation that sends the Starship toward the moon. This mission moves the project from digital models into physical hardware, providing the flight data needed to iterate on the heavy lift logistics of a lunar outpost. The destination is Shackleton Crater at the lunar South Pole. The crater rim receives near-constant sunlight, providing solar energy to run the bots 24/7. Nearby, permanently shadowed floors hold ancient ice, which can be processed into rocket fuel. Shackleton Crater marks the precise geographical intersection of sustainable power and the raw materials needed for a self-sustaining base. The Starship settles into the 1/6 gravity of the lunar surface, kicking up a slow-motion cloud of gray dust during its landing burn. As the ship powers down, the robots transition from standby mode to active deployment. The very first Grok bots step down onto the surface, leaving crisp, metallic footprints behind in the fine lunar soil. They immediately begin the work of unpacking equipment and starting the first phases of heavy construction. Deploying intelligent machines to confront the vacuum and radiation establishes the physical infrastructure and logistical safety net humans will eventually rely on to stay.